Okay, pre-calc. So our second part of first chapter, section 9, is going to be about absolute value inequalities and how to solve them. Now, they're going to be very similar to solving just linear inequalities, except now we're going to have an absolute value somewhere in the equation. And even more specific, we're going to solve them as a compound inequality. So remember, that was when we had an and or an or. Big piece here is you'll just notice the only two difference in these two statements is we have a less than or a greater than, and that could also be extended to less than or equal to and greater than or equal to. Okay, anytime it's less than, we're going to create an and inequality. So we just keep our x, drop our absolute values, keep our less than c, but we include to the left of it the and piece, greater than negative c. The opposite then, if it is greater than c, we're going to keep that, just drop the absolute value signs, kind of like absolute value equations. X is greater than c, or we switch the symbol and say it's less than negative c. So big piece here, the mistake that is commonly made is we need to make sure we are switching that symbol when we also switch the sign. So think about your absolute value equations. We always dropped the symbols and switched the sign. Now we need to switch the sign and turn that symbol around. Okay, so two examples here. You'll see the first one we have is less than 3. So when we have less than, we're going to make an and statement like we have here. So x minus 4 is going to stay less than 3, but we also want to say it's greater than negative 3. And that became an and statement. We solve it just like we did on the last video with compound inequalities. We're going to add 4 to both sides. So we're going to have greater than 1 or less, or and less than 7. Interval notation would be 1 to 7. We could also graph this solution if we wanted, and we would have, let's say, 0, 1, and somewhere out here we're going to end up with 7. Remember, there'll be open circles for both because we do not include the two values, and then we're going to graph in between them. Okay, so and statement on this one because it was less than, and we graph it in between because it's an and statement. Another big thing here, just like absolute value equations, before we can actually decide if we have an and or an or, you really need to make sure that you isolate the absolute value first. So we're going to subtract 7 on this first one, and that's going to give us less than or equal to negative 20 now, and then I'm going to divide by negative 2. Okay, just like compound and linear inequalities, when you divide by a negative, you need to switch that symbol. So now we have greater than, and remember from the previous slide, greater than tells us it's an or. So we're going to keep that 3x plus 5 is greater than or equal to 10, or big piece, 3x plus 5, and here we need to remember switch that symbol and the sign. So we didn't change anything inside the absolute value. We only changed the number on the other side of the inequality symbol. We solve them both like we have before. We're going to subtract 5 on this first one, so we're going to have 3x is less than or equal to negative 15. Divide by 3, it's positive, so keep your symbol the same way. And we get x is less than or equal to negative 5. The other side, 3x by subtracting 5. 3x is greater than or equal to 5, and then divide both sides by 3. Again, this is a positive number we divide by, so we don't switch our symbol, and we end up with 5 over 3. Okay, same idea. We could then graph our lines. We'd have a closed circle at negative 5 shaded to the left. We'd have a closed circle also at 5 over 3, which is 1 2/3 or 1.67, and we shade to the right. Okay, so big thing, absolute value inequalities. It is a combination of absolute value equations with compound inequalities. We talked about if it is less than, you're going to create an and statement. If you have greater than, you're going to create an or statement. But remember, before you can choose which one of those conditions to use, you must isolate the absolute value first. That's the big piece. Also, don't forget that when we divide by a negative number, you're turning your symbol around. All right, we'll see you in class.